Hello, 1050. This is section 5.4. We're going to be working with systems of nonlinear equations. So just two topics in this section. The first topic is solving a system of linear and quadratic equations. So we have a system here, y equals x squared minus 5x, and we have x plus y is equal to 21. So usually with systems that have a quadratic and a line, you want to use substitution to help you solve it. So we have y right here equivalent to x squared minus 5x. So we're going to sub that into our second equation for y. So we get x plus, now here's our substitution, x squared minus 5x, and that's equal to 21. So this is a quadratic equation now, and we can combine this term and this term together. We're also going to use factoring as a solving strategy here, so we want to have it equal to 0. So we're going to combine those two terms together and subtract the 21. So that gives us a leading term of x squared. This is a 1x minus 5x, so that's negative 4x, and then subtract the 21 equal to 0. Okay, so we're going to get our solutions by factoring. So our leading term is x squared, so we're going to put some x's at the beginning of each of our factors. Our constant is negative 21, so looks like we're going to be using a 7 and a 3. We've got a middle term of negative 4, so that's going to be a minus 7 and a plus 3. So each of those factors gives us one of our solutions or roots, x equals 7 and x equals negative 3. Now, when you go to type your answer into ALEKS, please note these are both x values. It's that we have two solutions to this system, and we need to report our answer into ALEKS. It'll just have a box like this, but you don't want to put the 7 and the negative 3 into this box. We have an x value of 7, so that will go here, but then we need a second solution box. So on ALEKS, you'll click on a thing that says OR, and then it will bring up a second solution box for you to type in your other x value. Now, each of those x values has their own corresponding y value. So remember, we have the equation x plus y equals 21. And so that means y is equal to 21 minus x. So for this equation, the y is equal to 21 minus 7, which is 14. And for this x value of negative 3, the y is equal to 21 minus negative 3, and that is 24. So make sure you do find the x values or the y values to go with each of your x values if you have more than one x value. Okay, I have another one of those for the video. I'm going to go ahead and do this second one. You can skip ahead if you don't want to watch another one. So these are both y equals a quadratic, y equals a line. We're going to, it is a substitution, but we're just basically setting those equal to each other. So x squared minus 5x plus 5 is equal to negative 2x plus 23. So we're going to add the 2x to both sides of the equation and subtract 23. So we have x squared minus 3x minus 18 is equal to 0. And so we can factor it. Let's see, factors of 18. This is going to be 3 and 6. And we have a middle term of negative 3. So our two x values are 6 and negative 3. So remember, that's two different solutions. So we need to click on the OR button to get our second solution box. So 6 and negative 3 are our x values. Y is equal to negative 2x plus 23. So y is equal to negative 12 plus 23. So that gives me 11. and y is equal to 6 plus 23, which gives me 29. So we got our two solutions. Okay, the second topic from this section is solving a word problem involving geometry using a system of nonlinear equations. And there's two variations that come up in ALEKS, so I'll show you one of each. So this one is about a rectangle. It says the perimeter of our rectangle is 14.2 and its area is 10.2 kilometers squared. Our job is to find the length and width. Okay, so let's call the dimensions of this rectangle x and y. So we're going to write a perimeter equation first. Well, perimeter is to add up all the sides, so 2x plus 2y is equal to 14.2. And we're already in decimal world over here, so I'm going to go ahead and divide that whole thing by 2, just because then the coefficients will be a little easier, and 14 divided by 2 is 7.1. So this is our first equation. Our second equation is going to be an area equation. Well, area of a rectangle is just length times width, so we have x times y is equal to 10.2. So that's our second equation. And we need to solve this system. So what we're going to do is we're going to solve this for x and do some substitution. Actually, let's solve it for y. Y equals 7.1 minus x. And now that we know what y is, we can substitute that into this equation for y. So we have x multiplied by 7.1 minus x, and that's equal to 10.2. We need to distribute. So we have 7.1x minus x squared is equal to 10.2. And we could, it's quadratic, so we need it to be equal to 0 so that we can apply the quadratic formula. We're not going to try to factor it because of the decimals. I prefer to not have a negative as my leading coefficient, so I'm going to shift everything over to the right side of the equation. So this will be 0 equals x squared minus 7.1x plus 10.2, and for some reason my decimal is in the wrong spot. Okay, so we're ready for the quadratic formula. I didn't really write what I was doing there, but there we go. Okay, so quadratic formula, our A coefficient is 1, our B coefficient is negative 7.1, and our C is 10.2. So x equals the opposite of B, so this is a positive 7.1, plus or minus the square root of 7.1 squared minus 4 times 1 times 10.2. And that's all over 2 times A. A happens to be 1 in this problem. So we need to crunch that in our calculator. And I get 5.1. I used the plus symbol. If I use the minus symbol, so 7.1 minus that root, I get the answer 2. Now, what's interesting here is that, the quadratic formula always gives you 2 answers for sure, plus one that you used addition and one that you used subtraction on. But in this case, I got my 2 x values, and the y values that go with those are each other. So like if x is 5.1, then y equals 7.1 minus 5.1. So y is 2 if x is 5.1. And if x is 2, then y is 7.1 minus 2, which is 5.1. So when you do the quadratic formula here, you actually do get the 2 dimensions of the rectangle because of the symmetry of this problem. In ALEKS, it doesn't matter which one you say is the length and which one you say is the width. So you could type it in either way and you would get the correct answer. All right, let's do one variation of that. Again, it's about a rectangle, but slightly different situation here. So we have a rectangle, the perimeter is 33.6, so 2x plus 2y is equal to 33.6. I like to divide that by 2 personally, just to make it cleaner. So x plus y equals 16.8. So that's our perimeter equation. And then on this one, it tells us about the diagonal of the rectangle, and our diagonal is 12. So instead of writing an area equation here, we're going to write the Pythagorean theorem. So here's our right triangle. Leg squared plus other leg squared is equal to the hypotenuse squared. So we're going to do a substitution again. So let's solve this for y. Y is equal to 16.8 minus x. We're going to substitute that here. X squared plus 16.8 minus x squared equals 144. So we're going to multiply out this binomial. I'm going to write it and then times it out. So we have an x squared. 16.8 times 16.8 is 282.24. We'll have a 16.8x that's negative, and another one of those from, let's see, we did that. Here's this and this. And then our last term will be an x squared. So we can combine our x squared terms. We can combine our linear terms, so that's 33.6x, that's the 16.8 plus the other 16.8, but they're both negative. And then I'm going to go ahead and subtract the 144. 282.24 minus 144 is 138.24. So now we can get our solutions from the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4 times a, oh geez, my handwriting, times c, and that's all over 2a. A is not always 1, so be careful. Sometimes people get in the habit of just writing that it's over 2, but it is over 4 this time. So we punch that into our calculator. And I get 9.6 when I use the plus, and do it again with the minus, or you can go back to one of your other equations, and I get, for the other one, 7.2. And just like in the other problem, because of the symmetry of this problem, those are actually my x and y values, because if x is 9.6, then the y value is 7.2. And if x is 7.2, the y value is 9.6. So it doesn't matter which one you say is the length and the width, ALEKS will accept it either way, and you'll have the correct answer. And that is it for this section. I'll make another video for section 5.5. Thanks.